Hello people! Welcome to this tutorial on making animated charts using Python. Today, we are going to create a bar chart race using only Python, Matplotlib, and Seaborn. Let's first look at the recipe for cooking this bar chart race. First, we would need an IDE. Any IDE of your preference would do, but if you're a beginner, I would suggest Google Colab. Secondly, we would need the data. We are going to use the World Population Dataset from Kaggle, which contains data from 1950 to 2023. Next, Pandas. This library is vital to load and transform the data. Most importantly, we would need the visualization libraries, Matplotlib and Seaborn. We can ideally achieve this using Matplotlib alone, but Seaborn gives us options to improve the aesthetics of the plot. Now, we know what we need. Let us look at our approach. First, we load and transform the data using Pandas. Next, we interpolate the data. The data we have chosen is at a yearly granularity. If we use it as it is, the transition between the frames of the video would not be smooth. So, we interpolate the data between 2 consecutive years. This is how we do it. We create equally spaced data points between the 2 years and add them as individual frames. This ensures that the transition between the frames is smoother. The higher the frame rate, the smoother the transition. In this example, we have used a frame rate of 4. So, we have 4 equally spaced regions between 2 years. For the actual video, we would use a higher frame rate, somewhere between 24 and 30, so that the video is much smoother. After this interpolation, we would end up with 4 interpolated data points per year. We plot the data we have for each year and frame combinations. Then, as the last step, we compile all those frames into a video. Because a video is actually a series of images shown in rapid succession. We could create all those plots, save them somewhere, and then compile them into a video. But the animation functionality of Matplotlib helps compile the frames into a video on the fly. Now, on to the exciting part. Code. I always write code in 3 separate sections: setup, code, and driver. The setup part contains the library imports and configurations. In this case, we import Pandas, Matplotlib, and Seaborn. We also import the animation module from Matplotlib. We configure the Seaborn theme and set global parameters for Matplotlib plots. Setting global parameters helps in eliminating the redundancy. Else, we would have to set them every time we need a value other than the default. The code part contains the modularized code. The entire code is contained in a class called Animated Charts. It has 5 methods and a constructor. The constructor, in it, takes in the parameters for the class and initializes the class. This is the part that is executed when a class is instantiated. The run method conditionally executes the other methods. The code in the class does not execute unless it is instantiated. In the driver part, we instantiate the class and pass parameters to it. The parameters are taken up by the init constructor during the instantiation. Then, we call the run method, which triggers the other methods according to the requirements. Let us dive deeper into the individual parts of the code. The init method takes in a dictionary of parameters and creates attributes of the class. In this case, we pass only the number of frames or interpolations between 2 consecutive years. We define the other attributes like a list of years, data, and a color palette, which we would be using throughout the class. Any variable that is used across multiple methods should be made an attribute of the class, and any attribute of the class should be defined in the constructor method. As the first step, we load and transform the data. We transpose the data from a country indexed format to a year indexed format. This will help us easily perform interpolations. This is how the data frame is transformed. To interpolate the data in Pandas, we need empty cells. So, we create dummy records for all year and frame combinations. Only for frame 0, we would have the data. For frames 1 through 3, there won't be any data. We achieve this in 2 steps. First, we make a Cartesian product of all years and frames. In Pandas, this is called a cross-join. The lines 35 to 37 build the cross-join data frame. In Pandas, cross-join can be done in 2 ways. In the older versions, we create a dummy key column on both the data frames, and it has constant values. We merge the 2 data frames on the common constant column, and we get a Cartesian product, or cross-join. In the newer versions, we don't even have to create a dummy column. There is an explicit merge type called cross. Then, we merge our population data with this cross-join data frame. When we merge these 2 data frames using year and frame as the key, we get the bottom right data frame. Initially, the values for frames 1, 2, 3 will be null, because we have the data only for frame 0. When the interpolation operation is performed, those empty cells will get filled. The interpolated values are denoted in red. Notice that the interpolation calculates equally spaced regions only when there is an upper bound. If the upper bound is unavailable, as in the case with 1951, the values are replicated. We can see that for 1951, the value of the frame 0 was replicated to the other frames. Next, we reshape the data. This is to enable filtering at a year and frame level. We used the Pandas function called melt, which is a reverse of the pivot operation. When a wide format data frame needs to be converted into a long format data frame, we use the melt operation. In this case, using year and frame as the key, we convert all the other columns into rows. The column labels are placed in a new column called country, and the values are placed in a separate column called population. The left data frame is in wide format. When we apply the melt operation on the left data frame, we get the right data frame as the result. Why is this required? The number of countries is more than what can be clearly represented on the plots. We are going to plot only the top 15 most populated countries in any given year. So, if the population is in a single column, it would be easier to sort and filter the column. The melt operation helps us with exactly that. Now, the most interesting part: creating and compiling the plots. First, we fix the layout of the plot. Since we are creating a video, we are going to choose a 1920 by 1080 resolution. This translates to a 19.2 by 10.8 matplotlib figure, with a DPI of 100. We also set the title that should appear on the plots. Next, we have 2 helper functions, init and animate. The init is an optional function that initializes the background of the animation. It is called once at the beginning, before any frames are drawn. This is useful for setting up elements like the background, initial plot state, or static parts that do not change with each frame. The animate function is where everything happens. The axis is initialized, the data is filtered, the bar chart is plotted, the bars are annotated, and the year is printed. There are some other cosmetic actions going on, which we will get back to in a while. To create the plots and compile them into a video, we use the FuncAnimation class from the Matplotlib animation module. It takes in some parameters. Some of them are a Matplotlib figure object, an animation function, an optional initialization function, the number of frames, and the interval between 2 frames in milliseconds. Once done, we save the animation object as a video file. The number of frames is vital, because the animate function is called that many times. For example, if the number of frames is provided as 28, the animate function is called 28 times. The value of the argument I ranges from 0 to 27 with each iteration. In our example, we are going to show the data for each year, for 1 second. We have considered 2 years, 1950 and 1951. Allowing a fade-out duration of 5 seconds, we will have 7 seconds of video. We discussed a frame rate of 4 to smoothen the transition. So, we would need 4 frames per second. Hence, the total number of frames needed is 28. So, we have fixed the size of the plot and set up an animation routine that compiles the generated plots into a video object. Now let us dive deeper into what goes on inside the animate function. First, we clear the axis object. This is to get rid of the modifications done for the previous frame. If not cleared, subsequent plots will be overlaid on top of each other, and it would be messy. We use the argument I to iterate over the year and frame combinations. As we already discussed, the value of I ranges from 0 to 28. Whenever the frame value becomes 0, which is after every 4 iterations, we increment the year by 1. Using the value of year and frame, we filter the processed population dataset. We pick only the 15 most populated countries, because plotting more than 150 countries on a single plot would look horrendous. To pick the top 15 countries, we sort the temporary data frame on the basis of population column and pick the first 15 rows. We create a bar plot with population on x-axis, countries' names on y-axis. We pass the country column as a value to the hue parameter to specify that each country should be represented in a different color. The palette parameter can be a built-in color palette or a dictionary. Here we have a custom palette to ensure that the color for each country remains the same across all the plots. After creating the plot, we annotate each bar. We know the value of each bar. We can get the position and dimensions of each bar from the patches attribute of the axis. We calculate the height and width of each bar and use it to display the value of the bar. None of these plots will make sense unless the year is printed. So, we use the text method of the axis object to write the year. At 80% of the width from the left and 10% of the height from the bottom, we write the year in black font and with a font size of 50. Since we do not need the X and Y labels, we set them to empty strings. This part is to add moving vertical grid lines. For every 200 million within the current range of population, we draw vertical lines on the axis, with accompanying text. This is how a sample plot would look like. For every iteration of the animate function, such a plot is created. When all the iterations are done, and the video has been compiled, it would look like this. This video is created from the complete dataset, but with a frame rate of 4. So the transition would be abrupt. To have a look at the video at 24 FPS, check out the video on the card, or on the description. Today, we learned how to create a bar chart race video using Python, Matplotlib, and Seaborn. Hope you enjoyed it. I'll meet you again with another interesting video. If you like what you see, experiment with it. Don't forget to subscribe. Until next time, happy learning!